Complementary DNA. What do we have to do? Well, we have to create a function that receives one side of DNA, and we need to return the other complementary side. Please note, A and T are complements of each other, S, C, and G. How to go about that? Well, first of all, I think about creating a dictionary, which will serve as a converter to convert all the DNA components to its counterpart. So let's go ahead. Converter is equal to, and let's put in all the key value pairs. The key would be the letter in the DNA string, and the value will be its counterpart. So let me go ahead. Yeah, there we have it. So now we have to iterate through the DNA. So for component in DNA, print the components. There we have them. But somehow we have to access the items in the converter as well. We can do that as follows for letter and its counterpart in the converter, and then use the .items method to access the keys and values within the dictionary. Let's print the letters and its counterpart. Yeah, and how about the components? Let's have a look here. And yeah, here we have to build in the conditions. So the letters should be equal to the component. And if that is the case, we should replace the letter by its counterpart and put it in a new string. So let's create new string. Let's call it complementary underscore DNA. So if the letter is equal to the component, then we should add the counterpart to the complementary DNA string. Oops. Plus equals the counterpart. Yeah, that is it. So let's return the complementary DNA string. Looks like it's working. Yeah. Well, let's test it out. Flawless. Hope this has been useful. If so, please consider dropping a like, and I hope to see you in another video. Ciao.